All right, we're starting a new unit, a new chapter into functions. Okay, so we're going to be talking about functions, and today's representing relationships with functions. So how can you use a graph to write an equation? So there's a main concept here that there's multiple representations. There's different ways of showing linear equations. We're going to start with that because that's what we're most accustomed to. So words, the distance traveled is equal to 12 miles per second times the number of seconds. So how far you travel is equal to 12 miles per second. So they're traveling really fast. What does that look like as an equation? Well, that would be the distance. D is equal to 12 times S, where S is the number of seconds and D is the distance in miles. So there's the words representation. Here's an equation of that same situation. The next one would be a table. I can say, look, I can make a table in 1 second, times it by 12, I get 12 miles. 2 seconds, 24 miles. 3 seconds, 36 miles. 4 seconds, 48, and so on. It keeps going. The last representation that we're going to talk about is graphing it. So once I have a table, I notice here that I can just plot my points, right? I make a little table. Time is here, goes this way, and distance is going up. So as I show here, 1 second is 12, 2 is 24, 3 is 36, 4 is 48. I can represent that in 4 different ways. So let's look at an example. The total cost of tickets to a school dance is shown in the table. So here's the table. Okay, so 1 ticket, $14.50, 2 tickets, $29, 3 $43.50, and 4 tickets, $58. This is the number of tickets and the total cost. What I want is, I want you to represent this information as a graph and then as an equation. So, simple as just plotting the points. We'll start with that. To make a graph, you just plot the points. You have to make yourself a little coordinate here. This is going to be the quadrant number 1. Number of tickets, 1, 2, 3, 4. And then the prices, I just went up by tens. And then I kind of just estimate where it's going to be, right? $14.50, that's somewhere between 20 and 10, not halfway exactly, a little less, so that's where I put that. 2, I go up, I say, well, it's almost 30, it's 29, so it's just below the 30 line, and then I go ahead and plot the other ones. I went ahead and put the coordinates there so you can see that, and I made sure to label my axis, both of them. And really what I should have here instead of instead of X, I should be using T, because I told you that's the variable we're using, and instead of Y over here, I should be using C for cost. So just to let you know, the letters could change depending on what you make them. Okay, so that's the way you graph it. Next would be your equation. Okay, so to find your equation, you got to find the pattern or the slope. So things that we've done before. And then work backwards to find the cost for 0 tickets. So what I'm going to notice here is if I listed those things, right, and all this information is from the table above. But if I list them again, I can notice that, look, it's changing by $14.50 each time that I increase by a ticket. So therefore, each extra ticket costs $14.50. And then I can think of this, well, look, 1 ticket, $14.50, so 1 step back at step 0, that means I had 0. I spent 0 money. And that makes sense. If I'm going to buy 0 tickets, it should cost me nothing. So my equation should be C is equal to $14.50T. Because you're going to take $14.50, and times it by the number of tickets. And that will give you your total cost. So there's your equation. So example number 2, and their last example today. A library charges a late fee of $3.50 plus 15 cents per day that a book is returned late. So I want you to write an equation to find the total late fee, F. So we're going to use a different letter instead of Y, for any number of days late, D. Okay, so here's my equation. My late fee is equal to $3.50. Okay, I got to pay $3.50 if it's late at all. And then on top of that, plus 15 per day. The word per there tells you for sure you're going to be multiplying. And I'm going to multiply by the number of days, which I decided to use the letter D for that. Okay, so my late fee is equal to $3.50 plus 15 cents per day. Next, I want you to make a table. All right, so find the total late fees if a book is 10, 15, 20, or 25 days late. So here I made a table. I just write on top, here's the number of days, 10, 15, 20, 25. Here's the function or the equation I came up with, $3.50 plus 15 cents a day. And then F is the late fee. This is like the equal sign. It's almost as taking this F and putting it over here and saying, look, I want I want to figure this out when I plug it in. What is the late fee? So one at a time, I plug them in. 10 goes in for the number of days. $3.50 plus 10 days at 15 cents gives you $5 when you do the math. I did it the same for 15, same for 20, same for 25. Again, I'm just multiplying these two together and adding $3.50. I'm multiplying these two together and adding $3.50. Multiply, add, multiply, and add. And those are my final outcomes. These are the different late fees for the number of different days there. Last one is I want to draw a table representing the situation. So if I graph this, not a table, a graph, I go ahead and graph it like this. I make my number of days here, late, 10, 15, 20, 25. The cost I kind of put here on the F-axis, or what normally would be my Y-axis, and I plot them. I go, okay, the first one was 10 days was $5, so 10, 5. Next one was 15 days, $5.75, and so on and so forth. I just go ahead and plot all of them, and I could then graph this, and it makes it a lot easier for me. So then later on, if I wanted to know 25 or 30 days later, then you could figure that out very quickly.